Hello. So today we're going to talk about the distribution of the sample mean. So what we need to look at is two things. We say that the mean of our variable, so we just have that we're going to look at the mean of the variable x bar is what we say mu. So that's going to be mu sub x, and this is going to be just whatever we calculate the mean to be. Now for the standard deviation, so the standard deviation of, so we'll write it like this, standard deviation of the random variable, well actually variable, x bar is, so we're just going to take that by notation, it's sigma sub x, and that's going to be equal to the standard deviation but divided by the square root of n. So the thing that we can add in here is that this right here is actually what we call the standard error. So whenever we talk about standard error, that's more or less just because it's the variation from estimating our mu with x bar. But in either case, most of the time, we don't really have to take it beyond, it's, you know, vocabulary word in that sense. So we just really say that it's a R just because, error, sorry, because we're using results from our sample statistic to estimate a population parameter. So that's why we tend to deal with like what we call sampling error and also standard error. But the purpose of this is just so that you kind of get an idea like what are the different things that you should look at as it relates to um, you know 8.1. So we have that the number of violent crimes committed in a day possesses a distribution with the mean 2.2 crimes per day and a standard deviation of 6 crimes per day. A random sample of 100 days was observed, and the mean number of crimes for the sample was calculated. Describe the sample distribution. So what we'll do is we'll just basically kind of write that we have that the mean is equal to mu, but we have that we're told that that's going to be 2.2 crimes. So we have that the mean is 2.2. The other is that we can say that the standard deviation, so the standard deviation is going to be sigma divided by the square root of n, but we have the standard deviation is 6, so that's just going to be 6, and that's going to be divided by our n, so we have that that's going to be the square root of 100. But this is going to give me 0.6. So what this tells me is that if I want to describe the distribution of the number of crimes committed, we'll say that it's approximately normal, approximately normally distributed with the mean to be 2.2 and the standard deviation of x equal to 0.6, and then that would be it. Now normally when we deal with a sample um, distribution, we just need to make sure that the sample is greater than or equal to 30. So we'll have that it just has to be greater than or equal to 30. Um, so let's look at this example where we have that the owner of a computer repair shop has determined that their daily revenue has a mean of 7,200 dollars and a standard deviation of $1,200. The daily revenue totals for the next 30 days will be monitored. What is the probability that the mean daily revenue for the next 30 days will be between 7,000 and 7,500? Okay, so let's actually write this out. So we have that we're trying to find the probability that 7,000 is less than our variable x bar, and that's less than 7,500. So let's just write this. So we have 7,500. And let's see. What we need to do here is just figure out what is the standard deviation. So we actually know what the standard deviation is and what the mean is as well. So the mean is going to be 7,200 and the standard deviation is going to be 1,200 divided by the square root of 30. Now that gives me that there's a standard deviation of 219.089023. Now we can actually show that using the calculator. So like if we take 1200 divided by the square root of, let's see, 30, and that's how I got that number. Now the next step would be that we need to essentially find the z-score for this parameters 7,000 and 7,500. So for example, if we use 7,000 minus the mean of 7,200 divided by the 219.089023, this is going to give me my lower bound, but I'm going to put this as z, and yeah, we can put lower. So we just need to figure out what this computation is going to give us, and then we're going to input it similarly for the upper bound. So we have 7,000 minus 7,200 divided by, so since I have my standard deviation already listed, I can just grab that, and we get negative 9.128. Okay, so that's going to be, let's do 4 decimal places, so we'll just do 9129. So that's going to be approximately negative 0.9129, and that's for the low. But we want to find also the upper. So the upper is going to be 75,000 or 7,500 minus 7,000 divided by the standard error. So 2.19.089023, and we're going to plug that into our calculator as well. So we have 7,500 minus 7,200, and this is all divided by the standard error. So divide, and we're just going to grab that because we already have it. Okay, so that's going to be 1.3693. $1.3693. So what that means is that our computation now becomes the probability that z lies between negative 9.129, and then we have that that's going to be z, and that's going to be 1.3693. Now, how do we do this? Well, we do it in the following manner. We have to use the normal CDF, and we're just going to use our upper limit and lower limit, so negative 9129, comma, let's move this a little bit, comma, our upper, so we have 1.3693, comma 0, comma 1, and then we just close it. Now what that's going to do is it's going to tell us exactly like what the area is. So let's do this. We'll do second vars normal CDF. Now our lower bound was negative 0.9139. Let me just check to see that that's correct. 29. Okay. Okay, so we have that that's going to be 29. And then we have 1.36. That one's 93. Let's just double check. Yes, okay. So the mean is going to be 0. The standard deviation will be 1. So this is what we have. We're going to hit enter. And we're going to get that this is 0.7339. So this is going to be approximately 0.7339. So what that does is it tells me that there's a 73.39 chance that the mean, or yeah, the mean for the daily revenue for the next 30 days will be between 7,000 and 7,500. Now, as you can see, like if we go back and we look at all of the work that was done just to find the probability, well, there is an easier way to do this. The easier way would have been to just say the probability of 7,000 is less than x bar and less than 7,500 is equal to normal CDF, and then we just put the 7,000, the 7,500, and now instead of putting the mean to be 0 and 1 respectively for the mean and the standard deviation, we're going to put that the mean was 7,200, and then the standard deviation was 219.08 and 9,023. Okay, so we'll just use our calculator to do that for us, and we have second vars normal CDF. So we have the lower bound is 7,000, the upper bound is 7,500, the mean is 7,200. So essentially this is just us not having to do the z-scores. 0.09, 0.08, 0.089023, and then we just hit enter. Well, let's see. That is very close to what we have. So it's correct up to 5 decimal places. But since I'm only using 4 decimal places, I get the same thing. So this is going to give us the same. So 0.7339. So both answers are correct.